Hello guys, welcome back to junkminds.com. Let us get started with one of the most important and one of the most fascinating concepts that we have in artificial intelligence in our syllabus today, and that is chapter number 3, searching techniques, which will include both the informed and uninformed searching techniques and the problem solving. Now this is the part 1 of this video. Make sure that whenever you are studying any particular topic, you study all the parts and in the sequence in which they have been given to you. Now to begin with, what exactly do you mean by searching techniques and what are the various searching techniques that we are going to study in this chapter? Now please understand this. The idea of searching that most of us have in programming is that we are given a set of values and then I'm required to locate a particular value. We've studied techniques like binary search, we've studied techniques like hashing and stuff. Or maybe we have a set of records and you are planning to search for a particular record. So that is another idea of searching that we have. But please understand this, that the idea of searching in artificial intelligence is very different from the concept of searching that we've been learning so far. The concepts that I just spoke about, they were in programming. You might have studied in some other subjects. But at the moment, what exactly are the searching techniques that we are going to talk about? What exactly do these techniques do? Please observe this. Now in these techniques, what we are planning to do is, I'm planning to solve a problem, and when I solve that problem, this is the initial state. And somehow I need to reach this goal state starting from this initial state. Obviously, while traversing from the initial state to the goal state, I can go through so many different intermediate stages, which will actually lead me from this initial state to this goal state. Now, whenever we are solving a problem, look at it like this. Now, when I start, I can go to various different options, what we'll later on call as successors. And then all these successors can lead me to the goal state. Now, going by this figure, I can say that there are 4 possible paths for reaching this goal state from the initial state. The aim of the searching technique that we are going to study now is to find the most optimum path for reaching the goal state from the initial state. Please understand this, that the condition of optimality is applicable at all times. Never ever an algorithm with a non-optimal solution acceptable to us. So we want the techniques to find the best possible solution for reaching this goal state from the initial state, and whatever techniques we study, this is exactly what they are going to do. So now with this little idea of what the techniques are going to do, let us get started with the first algorithm, which is called as the generate and test or the British Museum algorithm. Now please understand this, when we talk of the techniques, there are 2 different types of searching techniques that we have. Uninformed searching techniques and informed searching technique. This algorithm that we see is actually an uninformed searching technique. Now what exactly do we mean when we say informed searching techniques? I'll elaborate on this in the second part of this video, wherein I'll start with the informed searching techniques. But at the moment, generate and test algorithm. You can say generate and test is one of the most basic, a crude algorithm for implementing solutions in AI. Now please observe this. How do we start with generate and test? Just understand the concept. Now suppose if I'm starting with an initial state and my aim is to reach this goal state. Now how do I go about this? Now understand, on this initial state, which I'll also call as the current state. Initial state is the state where I start, and current state is the state which is currently being processed. So as I proceed with the problem, the current state obviously keeps changing, but initial state remains the same. Now there are so many rules applicable, there are so many operations possible. Now what I do is, I'll take first operation, I'll apply that operation, and then it may take me to an intermediate state 1. Now what I do is, I'll compare this state with the goal state. I'll check if this is the goal state. In our case, the state is not the goal state. Had it been the goal state, I would have returned the solution and stopped. But I found that this state is not the same as the goal state. What do I do then? I'll take the next rule, apply that, get a new state, compare it with the goal state. If it is the goal state, return it and quit. But if it is not the goal state, then I'll continue applying rules to this. I'll get this state. Again, I'll compare it with the goal state. Had it been the goal state, return it and quit. Else, you apply the rule, get the state. Moment I get a state which is the same as the goal state, I'll return that state and stop. So basically, your generate and test algorithm does not have a strategy as such. It keeps on applying the rules, it keeps on getting the new states, it keeps on checking those states, it will keep on comparing it with the current state. If they are the same as it will keep comparing it with the goal state. If they are the same as the goal state, return it and quit. else the process goes on till I've applied all the rules. Now, if I need to give you the algorithm, this is what it is. Start by selecting an initial state, generate a possible solution by applying a rule, test whether the new state is a goal state or a dead state. If the solution is found, then return it, else jump to step 2. Obviously, at some stage, either I'll find the goal state and I'll stop there, or maybe I'll come across a situation where I've used up all the rules and the desired state is not yet found. That is where I'll report a failure. So this is what is your generate and test algorithm. Needless to say, generate and test algorithm can be applied to only those problem domains where the number of states are lesser, the number of rules applicable are lesser, because this is precisely trial and error kind of thing. Now, if I keep on applying this in a larger problem domain, this is not going to work. So we need the better algorithms. We need better algorithms who have a proper strategy, who can generate solutions, who can generate optimal solutions even when the problem domain is higher. And that is what we are going to study in the next part of this chapter. But for all those techniques to work, they need to use a very, very, very important concept of heuristic function. So now, before I go ahead and discuss the algorithms, let me just take you through the idea of heuristic function. Now, first and foremost, what exactly is a heuristic function? Now, at the moment, just understand this. I'm trying to solve a problem. While solving those problems, I can come across multiple states in the problem and I need to choose between those. Now the argument is, how do I go about choosing the state? Now please understand this. When I'm comparing the states, I need a platform, a common platform on which I can compare those algorithms. And more importantly, I need someone who can help me compare the states. And that is what a heuristic function does. A heuristic function helps us compare any two states in the problem domain. A heuristic function is given like this: f dash of x is equal to g of x plus h dash of x. Now let me help you all with this expression. Now what exactly is this expression? See, suppose if there are two states and I need to compare them, what I'll do is I'll basically look at their f dash x values, and then whichever gives me the better f dash x value, I'll go ahead and evaluate that particular state. But then what exactly is g of x and what exactly is h dash of x? Observe, understand, something extremely important for the theory in the next part of the chapter, and extremely important for the problems and the numericals as well. Please observe this. Now here I start. Now suppose this is an initial state and my aim is to reach the goal state. Now for this intermediate state, say x, I'm planning to calculate heuristic function. See, when I say I'm planning to calculate the heuristic function, what I mean is I want the total path length or the total cost of the solution starting from the initial state going to the goal state via this intermediate state. So I'll first calculate the distance from the initial state to this node, which I'll call as g of x, right? Considering that x is the node, and the final distance, the distance of this state from the goal state, which I'll call h of x. So over here, if I need to give you the heuristic value or the value of the heuristic function for this state, I'll go like this: f dash x is equal to g of x, which is this, plus this. So basically, this value gives me the total cost of the path from the initial state via that node going to the goal state. Obviously, shorter the path, the better the solution. So lesser the value of the heuristic function, better is the state. So whenever I'm using any of the techniques, whenever they need to compare the state, they'll apply a certain formula, they'll get the heuristic value, they'll calculate the value for the heuristic function, and based on the values of the heuristic function, they'll go ahead and evaluate the solution further. So all the techniques that we are going to see now will be using the concept of heuristic function. So we will now go and apply this particular concept in so many other algorithms, but at the moment, thank you for learning with Junk Minds. This is the end of the first part. Meet me in the second part where I take you through all the remaining algorithms. Till then, keep exploring, keep learning. Thank you.